Alright? So look at this. Alright? So we can have this molecule. If we want another isomer similar to the alkene, we can just move the position of the functional group. So in this case, we can go the OH here. Alright, so this will be an isomer of this by just moving the functional group. Alright? But you could also have branch molecules. Right? But just to note that this molecule now would be 1, 2, 3, 4. And the name that we put next to the prefix is anal. Right? So it simply means that this would be 1, 2, 3, 4 is a bute. So it's bute. No. Right? And we should put the position, so it is 1 butanol. This one is indicating the position of the OH group. Right? This one is 2. So anal is the last part of the name. Alright? That would be equivalent to the ane in alkanes or the ene in alkenes. Alright? And then the branch, I'm not going to bother to stress about the branch for these, but it's the same principle. Alright? You would have to put the alkyl group in front of this. But you can do it for your homework. Alright? Clear? So these will be isomers by moving the position of the OH. Alright? And then if you want me to write the condensed formula for this, so the condensed formula. So this is the structure, full structure. For this one it will be CH3, CH2, 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 OH. Then for this one, CHOH in bracket. Now remember that the branch is always branch or the functional group always go in bracket if it's not at the end. Alright? So the functional group or the alkyl group can go there. So you basically got the introduction. So homologous series, the 4 different types that we are focusing on, how to name them, the general formula, the functional group. These are stuff that you have to read and remember. Alright? And know how to apply them in real life. About catenation, structural isomerism, these are all terms that you have to know, like the prefix that they use to number carbon, methyl, ethyl, propyl for the branch, or the met, eth, prop for the long chain. Alright, you have to know all of this stuff. Carboxylic acid. Thinking of the alkanoic acid, right? So functional group C double bond O. So So it's like the alcohol in which oxygen is on that N carbon atom. Additional stuff to form. Because the former, I don't want to jump into the reactions. The move from alcohol to an acid is oxidation. Oxidize it. Alright, but that's for next class. General formula. And then let's just name some of them before we go. Alright? So like take say have so the ethanoic acid is what we find in rum. Alright? And then I want you to look at the alcohol bottle at home, your homework, and draw the structure of that alcohol that is there. Isopropyl. Vinegar, ethanoic acid? Yes, acid. It's acid. But in rum it's the ethanol, sorry. I said the acid was in rum? No, sorry, my bad. This is vinegar. It's the ethanol that is in rum, which is the alcohol. Sorry, my bad. Alright. Here you have propanoic acid. So you have C. Sorry, wrong again. Alright. So it's 1 carbon, ethanoic acid, 1 carbon, ethanoic acid, 2 carbons. Propanoic acid, 3 carbons, right? Alright, questions. Can we form isomers of carboxylic acid by moving the position of the functional group? Or it has to be the branch? Alright, you see, unlike alkenes and alcohol, which you could just move it along the straight chain, it's not possible for the carboxylic acid. And you can go home and figure out why. Just try to do it and you will see it won't work. Alright? But remember that in addition to these, we could have longer molecules with branch, and the same principle will occur. Alright? Any questions? Let me just read through the objectives from the syllabus to see if you think we have touched all of them. Alright? So it said to illustrate that carbon atoms can form single and double bonds, branch and unbranched chains, and ring compounds. We probably didn't look at any ring, but we will see those in terms of going to reactions. Right? Write formula to represent simple organic compounds. We have represent all the formula, the molecular formula of condensed structure, full structure. List the general characteristic of a homologous series. That's what I gave you for your homework. Write general and molecular formula for members of a given homologous series. We have done it today. Alright? Deduce the homologous series given the fully displayed and condensed formula of compounds. You should be able to do that because we have look at examples from all the 4 homologous series that we're looking at. Write fully displayed structures and names of branched and unbranched alkanes and unbranched alkenes, alcohols, and alcoholic acid. So even when I was branching it, you don't need to know that for CSEC, but it's good knowledge to have. So write fully displayed structures and names of branched and unbranched alkane, and it's unbranched alkene, alcohols, and acid. So we don't need to know. It's the one that I'm giving you with the branch, with the alcohol. You don't need to know that. Alright? Define structural isomers. We did that. Write the fully displayed structures of isomers given their molecular formula. Alright? So remember that example that we use with the molecular formula for the pentane, that one that we're doing for the alkane, that's what they're talking here. So if they're giving you that molecular formula, you're supposed to be able to derive all the different isomers. So remember that how you derive it with molecular formula, you just write the skeleton of all the different carbon atoms that are in the molecular formula. So if it's 6 carbon atoms, we just write all the different possible arrangement of the 6 carbon atoms. Then we add hydrogens to complete 4 bonds around each carbon atoms. Alright? Alright, thank you.